Okay, so far we've been looking at trying to figure out how much money we would get from a given interest rate and a given amount that was invested. But what if we go the other way and we try to solve for R? So suppose we invest 900 bucks and we need to have $1,000 after 4 years. What interest rate do we need in order to do this? Uh, I left out a bit of information here. Compounded monthly. If we don't know the compounding period, we can't really answer the question. So let's look at this. We've got A, P, R, N, T. In this case, we know the thing we're trying to solve for is R. Our accumulated amount, we want it to go to 1,000. We want our interest to be, or I'm sorry, we want our principal to be 900. N is 12 and T is 4. So if I plug into my equation, A equals P times 1 plus R over N raised to the NT. Now there are a couple of ways you could solve this, but one involves logarithms, but the other one involves roots. So let's do this. First up, let's divide both sides by 900. So we get 10 over 9 equals 1 plus R over 12 raised to the, let's go ahead and multiply that out to 48. So now I need to get that R. So I need to get rid of that 48. What I'm going to do is on both sides, I'm going to raise this to the 1 over 48 power. What that's going to do is turn this over here into 10 over 9 to the 1 over 48. This side is going to be 1 plus R over 12. All right. 10 over 9 to the 1 over 48. 10 divided by 9 gives me this, raised to the 1 over 48. All right. This gives me the number 1.002197422 equals 1 plus R over 12. Now, rather than writing all this out again, I'm just going to take this and do it on my calculator. So the number I've got here is R over 12, 1 plus R over 12. So I'm going to take 1 from it, and I get 0.002197422 is R over 12. So I'm going to multiply that times 12, and I need R to be 0.02, I'm going to round off here, 637. So if I change that to a percentage, I need it to be 2.637%. Now we'll see in another couple of sections, there's another way to do this problem, but this is one way that's perfectly fine. Let's also look at radioactive decay. Radioactive decay works the same way as exponential growth, except for its exponential decay. The equation we're going to use is similar, but A is equal to PB to the T. Now in this case, B is going to be something that's unknown, so we'll have to come up with B. But let's do 2 examples of this. A scientist has 100 milligrams of a radioactive substance that decays exponentially. 35 hours later, 50 milligrams of the substance remains. How many will remain after 54 hours? All right, so first up, we have to find B. My cat, I don't know if you can hear my cat, she's demanding attention. Find B. All right, so like this, A is the amount we have at time t. and P is the initial amount, just like before. So if we have 50 milligrams, the initial amount was 100, and that's times B to the T. T was 35 hours. So we have to solve this. So first up, divide both sides by 100. You get 1/2 equals B to the 35. Now to solve this, raise both sides to the 1/35 power. So I get B is equal to, on my calculator, I'm going to do 1/2, that is 0.5, raised to the, let's see, there's several ways I can do this. I like to avoid fractions on my calculator, so I'm going to do it as 0.5 raised to the 1 divided by 35. So I've got it looking like this. When I hit enter, it gives me this number. .98039. That's close enough. All right, but then it asks how many milligrams will remain after 54 hours. So I've got to use the equation again, and I'm going to say A equals P times B to the T. So now I'm just going to take the amount that's on my calculator here. I'm going to take that and raise it to the 54th power. And I get like 0.34 something. And I'm just going to take that and multiply it by 100. And I get 34.321 milligrams. All right. And notice this one, it kind of set us up. It gave us 100 milligrams. Then it said after 35 hours, 50 milligrams were left. So 35 is the half-life of this stuff. Now, this next example, they give us different values, but it doesn't matter. It works the same way. The scientist has 20 grams, and after 15 minutes, 18 grams are remaining. So if we do A, P, B, and T, first up we got to find B. We know that we started with 20, wound up with 18. That was after 15 minutes. Now, as long as we keep the units the same, it doesn't matter if we use minutes or hours or years or whatever. So let's solve this for B. 18 equals 20, B to the 15th. So divide both sides by 20. I get 18 over 20, which is 9 over 10, equals B to the 15. Raise both of these to the 1 over 15. And I get B equals, let's see, 9 over 10 to the 1 over 15. I get 0.993, then several zeros, and then some other numbers. I'm just going to keep that on my calculator, though. I'm just going to keep that number in there, and we'll use it on the next part. How much will remain after 3 hours? So the amount we start, the A is the amount we're looking for. P is what we started with. That's 20 grams. B is 0.993, etc. And T in this case is 3 hours, but since we've been using minutes before, we need to convert that into minutes. So it's 180 minutes. So A in this case is 20 times 0.993 to the 180. Now I've still got that 0.993 with the additional decimals on my calculator. So I'm going to take that and raise that number to the 180. I get 0.282 something, multiply by 20, and I get 5.6485, let's just say 5.649 milligrams. This is not a science class, so I'm not going to worry about significant figures and stuff. On a test or something, I will ask you specifically, or I'll give you specific instructions on how many decimals to use. All right, I'm yawning, so that's probably a good sign that I need to stop this video now.